Good morning, students. So myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today we are going to discuss about the Fourier series. We already discussed about the Fourier series and some examples on the Fourier series. See, the yesterday class, we seen one example of the Fourier series. Now, another example on the Fourier series to determine the trigonometric form of the Fourier series or the trigonometric Fourier series of ramp signal. Yesterday we seen the trigonometric Fourier series for exponential signal, exponentially decaying. And I have to remember here, Fourier series means it is used for analysis of periodic signals, analysis of the periodic signals. Now you can observe here the given diagram is the trigonometric Fourier series of ramp signal. We know the ramp signal is from origin to the, if t is increases, x of t is also increases. Ramp means we have a slope. We already know it is a slope. At t is equal to 0, x of t is also 0. And t is equal to 1. T means the small t, the variable of t. If the signal having a ramp function, the ramp is r of t is equal to t. We know r of t is equal to t. Means the t is varies correspondingly the x of t, or that x of t we can assume as a ramp signal. R of t is also varies correspondingly as a linearly, we can say. Linearly changes. Okay. Now let's see here, you can observe a ramp signal from 0 to t, 0 to capital T, with the duration of the time period of the t, having a slope up to the value of magnitude is a is there. So it's on here. So let us assume this is a graph, a slope 0. It starts from the 0 as varies the t value, and x of t, the given x of t as a ramp, a slope up to the period of the t, and is again repeated. So repeated means for every time interval of the t, the plot is repeats. You can call it as a periodic signal. And what is the amplitude of this one here? Given it is a is the amplitude. We know the straight line equation, the y is equal to mx plus c. We already know y is equal to mx plus c. Or another formula is there for a straight line, y minus y1 by y1 minus y2 is equal to x minus x1 by x1 minus x2. Or we know the y is equal to mx plus c, where m is a slope. Y minus y1 is equal to m. M is nothing but x2 minus x1 by y2 minus y1. Okay, into x is there, x minus x1. This is the formula we have actually. That is y minus y1 is equal to m into x minus x1, where m is a slope here. What is the slope? y2 minus y1 by x2 minus x1. y2 minus y1 by. See, the y minus y1 is equal to What is the slope? I am saying the y2 minus y1 by y2 minus y1 by x2 minus x1. All multiply with the x minus x1, my dear students. Why I am taking the straight line equation with the slope, the given graphical representation, a ramp signal we have with a period of 0 to t, and it is repeated with the same interval of t, and it is a periodic signal. To find out the trigonometric Fourier series of the given ramp signal, you have to take the straight line equation y is equal to mx plus c, or the y minus y1 is equal to m into x minus x1. I'm not taking the constant here. So y minus y1 is equal to y2 minus y1 by x2 minus x1. This is the slope into x minus x1. Or otherwise, we can write it as y minus y1 is equal to, here I wrote the y minus y1 by y1 minus y2. We can take the cross multiply here. Cross multiply. But it is not the y2 minus y1, it is a y1 minus y2. So y1 minus y2 and x1 minus x2. So I take the common of minus here, it changes as y1 minus y2, and here it is x1 minus x2. So both are the same. Nothing is a difference. So y minus y1, I'm changing with the sign here, y1 minus y2. Already we have is equal to, here in the numerator, x minus x1, and the denominator, I change it is y1 minus y2. So here also you can change x as x1 minus x2. x1 minus x2. This is the same equation what I wrote here. Don't confuse my dear students. This is the equation we got from the straight line equation, y is equal to mx plus c. In that, m is the slope of that equation. Understood? So what is the values of quadrants of, let us see here, I taken it is a P as a one quadrant, and here the Q is another quadrant of that slope. What is a P? P having the quadrants are 0, 0, because it's at the origin. And what is the quadrants of Q here? Q is equal to x-axis. First of all, you can take it as x-axis, that is a T, and in the y-axis is a A. These are the two quadrants of the given characteristics, or it is a graphical representation. The P is at the origin and the Q is at the time period of T, the magnitude is a A. Now you can substitute these are values of x1 and y1, and these values is not the x1 y1, the x1 and x2, okay, the x1 and y1 only, and x2 y2. Now you can substitute the values as of y. What is the y here? Y is nothing but y-axis. In the y-axis there is a x of t signal. So I substitute the y as x of t. You see here, x of t minus, what is a y1? Y1 is a 0. 0 whole divided by y1. What is the y1? Y1 is a 0 minus y2. Y2 is a A. Y2 is a A here. Following my dear students. And take the quadrant is a P is a 0, 0, and another quadrant Q is a T, comma A. Then we consider the points P and Q. Following. So I am substituting the values of y1, y2 and x1, x2 in the equation of straight line. Here the y is in the x-axis, there is a signal x of t. So x of t minus 0, x of t minus 0 whole divided by y1. Y1 is again, it is a 0 minus y2 is a. Y2 is a is equal to x minus x2. What is the x here? The t variable. X is the t variable. So t minus x1 0. X1 is a 0 is a x variable. In the x-axis, the t is a variable, and the y-axis, x of t is a signal. So for y, I am taking here x of t, and x is the t, and remaining is the quadrants. What is x1? X1 is a 0, whole divided by x1 is 0 minus x2. What is the x2 here? The t. So after substituting, simplify this equation as x of t by a is equal to small t by the capital T minus. Okay, so before that it is x of t by minus a is equal to t by minus t. Alright, minus and minus here, the plus, cancel that minus and minus, becomes it is a plus. So x of t is equal to cross multiply at by the capital T. What is the signal now? We got x of t is equal to at for t is equal to 0 to t. This is a total signal is the slope is a capital A small t whole divided by the capital T for all the values of t from 0 to capital T. We got the slope equation x of t, or the signal equation for the given graphical representation. X of t is equal to at by the capital T. And to find out or to determine the trigonometric Fourier series, you have to find out a of 0, a of k, and b of k. Finally, you can substitute in the x of t equation to get the trigonometric Fourier series x of t is equal to. So first of all, the evaluation of the a of 0. What is the formula for the a of 0? 1 by t integral 0 to t x of t dt. 1 by t, what is the integral? We are taking from the 0 to t only, the response. 0 to t, the x of t is a at by capital T into dt. Here the a by the capital T is a constant. A by capital T is a constant. So it becomes of 1 by t into a into t is as a by t square. A by t square with the integral of 0 to t, t into dt. T into dt. The integral of t. So integral of t is the 4 power 1. We know t power n dt. T power n plus 1 by n plus 1. The integral of t power n dt. T power n plus 1 by n plus 1. Here the t power is a 1. 1 plus 1, the t square, whole divided by 1 plus 1 is a 2. Upper limit is a t and lower limit is a 0. After substituting here, a by t square into the t as t square by 2 minus 0 by 2 for the lower limit. The lower limit is a 0 here. T square and t square get cancelled, a by 2. Finally, the a0 is equal to, we got a by 2. The remaining function, the an and the bn, to see, an. What is the an? An is equal to, we have the formula is there, 2 by t integral t x of t and cos n omega naught t. Cos n omega naught t. Omega naught. What is omega naught here? Omega naught for continuous, or otherwise for digital, the omega naught. Here they use the omega naught symbol is like this. Cos n omega naught t. Cos n omega naught t dt. and omega is equal to 2 pi f. But this is also the 2 pi f only. And the 2 pi f by the t, the f is inversely proportional to the time period. With the t, the 2 pi by the t. You can take as a omega. Otherwise, you see the sine n using the omega naught is a 2 pi by the t. Don't confuse here. So now, the integral is two parts. X of t is equal to, we already got the at by the t and cos n omega naught t dt. The two terms is there, the t into cos omega naught t. According to the uv rule, see the uv rule, integral uv. U you can take as a t and v as cos cos n omega naught t. Cos n omega naught t dt or cos k omega naught t dt actually. So don't confuse my dear students here. You see, this actually it is a suffix k. If a suffix k is there, the n value, whatever you are using, the cos k omega naught t. If otherwise, if I am taking that as a n, it cos k omega naught t dt. If I am using the an, it becomes of cos n omega naught t. So both are the same. Simply the k is a variable and n is also the variable, and omega naught and omega naught is a different, but the equation is the same. Omega naught is equal to 2 pi f, and this omega naught is also the 2 pi f with the time period of the t as inversely proportional to the frequency 2 pi by the t. Don't confuse here. Okay. So in this the t we can take as a u and cos n omega naught t dt as v. What is the formula here? Integration by parts we can call it as. Otherwise, the uv rule. U integral v minus integral of the derivative of u and the integral of v. This is a total function. So only the single function is. First of all, you can take the integral. In that integral, apply the derivative of u and apply the integral for the v. That is a total second function. The first function is u integral v minus integral of derivative of u and the integral of v. This total function is integration by parts, we can call it as. See here, again, a by t is outside, becomes of 2a by t square, 2a by t square. The first one, see, 2a by t square, u as the t, and integral 0 to t. What is the v here? Cos n omega naught t dt minus, the second term is integral of the derivative of t. What is the derivative of t with respect to the t? 1. And apply the integral of v here. What is the v? Cos omega n omega naught t. The integral of cos is the sine. Sine n omega naught t, and coefficient of t can write as in the denominator. N omega naught into dt, and apply the integration as a 0 to t here. In this, the second term itself, they have to apply the 0 to t. Then you can close the brackets. Is equal to an is equal to 2a by t square t, and for this first term, integral of cos is a sine n omega naught t, and the t coefficient you can write in the denominator n omega naught t. For this also there is a limitations is there 0 to t, and here again you can apply that the integral of sine. Again you can apply that it is an integral of sine, my dear students. Integral of sine is a minus cos n omega naught t, and T coefficient is a n omega naught. Already we have n omega naught in the denominator. Now it becomes of n square omega naught square. So for this total function, take the limitations as 0 to t. 0 to t. Don't confuse. I apply here only the integration by parts. Or otherwise UV rule. U as t and v as cos n omega naught t. In this equation, I substitute as u as t, v as cos n omega naught t. And here the derivative of u is 1 and integral of v is sin n omega naught t by n omega naught t dt. Why I am using again the dt here, the other integral is there. Okay. Now coming to the next line, the 2a by the t square, the t I directly write here and apply the integral of cos is a sin n omega naught t by n omega naught minus integral of sin, we know the minus cos n omega naught t whole divided by the t coefficient here n omega naught. Already we have the n omega naught is there. So multiply those two n square omega naught square, apply the limits of 0 to t. Fine. So now you see here the 2a by t square, substituting the omega naught is equal to 2 pi by t. Substituting the omega naught is equal to, or the digital omega naught is equal to 2 pi by, first of all, you know the 2 pi f, that is a 2 pi by t. 2 pi by t. So sin n 2 pi by t here, and cos n omega naught is 2 pi by t, and here also another omega naught is there, 4 pi by t, 4 pi square by t square, and here also the omega naught, I have to substitute this omega naught is also the 2 pi by t. The 2 pi by the t means all it is changes in terms of small t and the capital T. Now apply the upper limit and the lower limit. First of all, you can apply the upper limit for these two terms. The first term is small t is there, the variable. You have to substitute with capital T because the upper limit is a t sin n 2 pi by the t, and here the small t is there, replaced with capital T and n 2 pi by t. Plus, for the same upper limit, you have to apply for the second term also. Cos n 2 pi by t, the t is replaced with the capital T and whole divided by n square 4 pi square by t square. These two terms for upper limit of the t. And the remaining two terms we here, for the lower limit, minus t is there. T means 0. 0 into anything is a 0 here. Minus second term, cos 0 by n square 4 pi square by t square. You know the cos 0 is a 1. Cos 0 is a 1. So in the next equation, 2a by t square, and in this t into t is a t square, 2 pi by n, not the t square here, my dear students. Actually, this t becomes of, goes into the numerator. The t square, t into this t is a t square, denominator is a 2 pi by n, sin n 2 pi, and these two get cancelled here. This t and this t get cancelled. And in the denominator, we have the t is there, get in the numerator, t square by 2 pi n, sin 2 pi n, plus the second term we can observe here, and this t is get cancelled here. And the t square in the denominator will get in the numerator, t square by n square 4 pi square, cos n 2 pi minus 0. And the fourth term, the cos 0 is a 1. And in the denominator, we have the t square is there. We get in the numerator the t square by n square 4 pi square. N square 4 pi square. We already know the sin pi, any factor you can multiply here. always the value is a 0. You see here, sine 2 pi is a 0. And cos 2 pi is always 1. Any factor it is multiplied here. Cos 2 pi is a 0, cos 2 pi is a 1, sorry, and sine 2 pi is a 0. So first term is a 0 here. The first term is a 0 since we have the sine 2 pi is there. Alright. And the third term is already the 0 here. And only remaining the two terms, that is second and the fourth term. In that second term also, cos 2 pi and the value is a 1. Since cos 2 pi is always a 1. So second term coefficient is there, t square by 4 pi square n square minus fourth term t square by n square 4 pi square. These both are the same. It is a plus value and this one is a minus value. So minus and the plus is a 0. So an is equal to 0. An is equal to 0. Got it, my dear students? So we have the formula is there, a suffix k actually. Here I have taken it is a an. When I am using the n variable, the omega naught symbol is different from the angular frequency. When n is used, it is a omega naught. And the t is used the omega naught. Both are the same. Nothing is the difference. So after simplifying the equation of an, the 2 by t, the integral t, by taking of x of t as at by the t and cos n omega naught t dt, these two functions as in the form of integral uv. After simplifying, we got an is equal to 0. An is equal to 0. Now coming to the last one, the bn. Bn. What is the bn formula? 2 by t the integral t x of t, and here it is a sine function. An having cos function and bn having the sine function. So again, use the uv rule. U is x of t, nothing but at by the t, and sine n omega naught t dt. Take the a by t is in the outside because this is a constant. Again, I am using the same equation here, whatever. That is integral uv, u as t, t into integral v. Now the integral v is a sine function. Sine, integral of sine is a minus cos n omega naught t, and the coefficient of t is n omega naught. Minus, and here the integral, inside the integral, derivative of u and integral of v. What is the derivative of u here? 1, because it is a x of t is a t, 1, and integral of sine minus cos n omega naught t, n omega naught, and the dt, because another integral is there. Take the limitations of 0 to t. And here the minus is there, minus t, cos n omega naught t, n omega naught. And the minus and minus, both it is a plus. Integral of cos. What is the integral of cos? Again, the sine. Sine n omega naught t. The denominator already we have n omega naught. Now with this integral, we got another coefficient n into omega naught. So n omega naught into n omega naught is a n square omega naught square. Apply the integral 0 to t. Not the integral, the limitations 0 to t. Okay. Now coming to here, substitute the upper limit as a t, 2a by t square. Upper limit is a t minus t cos n 2 pi by t into t, n 2 pi by t. This 2 pi by t is omega naught, my dear students. For the second equation, You see in the second term, the second term is there, sine n omega naught t by n square omega naught square for the t also, upper limit only. Sine n omega naught t by n square 4 pi square into t square plus next two terms is for the lower limits. For the lower limit, the t is there, t into anything, nothing but 0 into anything is a 0 minus sine 0. Already we know the sine 0 is also the 0 only. So last two terms becomes is a 0 and the first two terms you can observe here, there is a sine 2 pi is there. That sine 2 pi is also 0 we know, and cos 2 pi is a 1. Cos 2 pi is a 1. So Bn is equal to 2a by t square minus t square by 2 pi n, and cos 2 pi is a 1 and sine 2 pi is a 0. Cos 2 pi is a 1 and this one is a 0. So there is no any second term. And the third and the fourth is also there is no anything. And we have only the t square by 2 pi n. And in this, 2 to get cancelled. And the 1 t, here also the t square and t square is get cancelled. The remaining terms is a by pi n. So Bn is equal to minus a by pi n or n pi. Following my dear students. And if this variable is varies, Bn is B1 minus a by pi, B2 is minus a by 2 pi, and the B3 is minus a by 3 pi, and so on. And what is the equation of x of t actually? The trigonometric Fourier series is a of 0 plus sum of n is equal to 1 to infinite a of k or an. Okay, we are using here the an, so you can write as an only. An cos n omega naught t plus sum of n is equal to 1 to infinite Bn sine n omega naught t. Following my dear students. Here there is no any dt, it is wrong. Only the function. What is the a naught? We got the a naught is equal to, clear here, a naught value a naught is equal to a by 2. You see here, a naught is equal to a by 2 and an is equal to 0 and bn is equal to minus a by n pi. Substitute all the values here. A naught is a by 2 and an is equal to 0. There is no any second term here. An is equal to 0 and third term sum of n is equal to 1 to infinite bn sine n omega naught t dt. What is a bn here? B1, B2, B3 and so on. Or otherwise directly you can substitute x of t is equal to as a naught plus sum of k equal to 1 to infinite an cos n omega naught t plus sum of k equal to 1 to infinite bn sine n omega naught t. Following my dear students. What is a naught? A by 2 we got. Capital A by 2 plus what is a an? 0 plus sum of k equal to 1 to, or not the k, it is a n. I use here the n, so don't use the k here. N is equal to 1 to, and here also n is equal to 1 to. So n is equal to 1 to infinite. What is a bn? We got bn is a minus an minus a by n pi minus a by n pi multiplied with the sine n omega naught t. This is the total final expression of the trigonometric Fourier series. X of t is equal to a by 2 plus 0, and expanded this function as n is equal to 1. N is equal to 1 is a by minus a by pi sine omega naught t, because n is equal to 1. A by pi sine omega naught t. And if it is n is equal to 2, n is equal to 2 sine 2 omega naught t by 2 a by pi. And third one is sine 3 omega naught t by 3, and so on. So x of t after expanding the n is equal to. Following, my dear students, is also very, very important example. The previous class, yesterday's class, we find the trigonometric Fourier series for the exponential function, and it is a periodic with a period of 0 to 0.5. Now, in the today's class, we find a ramp signal given the x of t with the amplitude of a and with a period of 0 to t. 0 to t, and it is also the periodic signal only. Not like this, this is the right periodic signal. So always the Fourier series is available for the periodic signals only, because the Fourier series is used to analyze periodic signals. These two examples is very, very, very important, my dear students. Please practice these two questions 2 or 3 times. Otherwise, it is somewhat difficult to learn. Okay, come to the next one. Obtain the polar Fourier series of the signal. So Fourier series is 3 classifications. One is trigonometric Fourier series. Another one is compact trigonometric Fourier series, is also called as polar Fourier series. And third one is an exponential Fourier series. In yesterday class, we already find the Fourier trigonometric Fourier series of these characteristics. The given characteristics what we have here. This is for exponentially decaying function with the time period of 0 to 0.5. With the time period of 0 to 0.5, we find a naught is equal to 0.7869. An is equal to 1.576 by 1 plus 4 pi k whole square. Not the whole square, it is a whole square for the second term only. And Bn is equal to 6.32 pi k by 1 plus 4 pi k whole square. These are the 3 factors we got. A naught is equal to 0.7869 and an is equal to 1.576 divided by 1 plus 4 pi k whole square here. For these only, these are only term. And Bn is equal to, or the B suffix k is equal to, we got 6.32 pi k. So if we are using the k value, there means this value is also k only. A suffix k and the B suffix k. 6.32 1 plus 4 pi k whole square. Okay. These are the 3 terms we already find by using these characteristics, exponentially decaying with a period of 0.5. So using that, obtain the polar Fourier series. Obtain the polar Fourier series is converting of a rectangular form to the polar form. A naught is equal to same as D naught. A naught is the same as a D naught. But AN and BN we have in the trigonometric Fourier series, but in the polar Fourier series it becomes of DN or it is a CN. Okay. This is a D of 0 and this one is a D of K. What is a D of K is equal to under root of the magnitude. If X plus IY is a rectangular form, if X plus IY is a rectangular form, what is a polar form in the magnitude? The magnitude is X square plus Y square, my dear students. And the phase angle is minus tan inverse Y by X, imaginary coefficient and the real term. Ratio between of imaginary coefficient and the real coefficient. So in this, the D of K is equal to under root of A of K square. What is A of K here? 1.576 by 1 plus 4 pi K whole square. So numerator is a 1.576 square, 1 plus 4 pi K, and here it is a square and a whole square, plus B of K. What is a B of K here? 6.32 pi K whole divided by 1 plus 4 pi K square whole square. This is the second term. Simplify this one. We'll get A of K or the D of K is equal to under root of 1.576 whole square 1 plus 4 pi K whole square by 1 plus 4 pi K square whole square. And these two get cancelled here. One term. This is a 1 plus 4 pi K square and here one square term is there. So D of K is equal to under root of 1 plus 1.576 whole square divided by 1 plus 4 pi K square only. Means whatever the A of K, that is a D of K. After simplifying. And pi of K is equal to, in that pi of K, minus tan inverse Bn by An. Nothing but Bk by A suffix K. What is a B suffix K here? 6.32 pi K by 1 plus 4 pi K square. So in these two functions, denominator is the same. Denominator is the same. So tan inverse minus tan inverse actually, minus tan inverse A of K, B of K is a 6.32 pi K whole divided by, and the A of K, the term, the numerator is 1.576, because actually both having the same denominators will get cancelled. See, 1.576 is 4 times, you will get the 6.32. 4 times is a 6.32. You can use the calculator, you can find out 4 into 1.576 is nothing but 6.32 only, my dear students. So pi of n or pi of k actually it is, because here the term is a k. Pi of k is equal to tan inverse 4 pi k, and A of k is equal to under root of this term, and D of 0 is not the A of k, my dear students, it is also the wrong. It is a D of k. D of k is equal to, and D of 0 is equal to. Now using these three functions, we write a trigonometric Fourier series, not the trigonometric, compact trigonometric Fourier series or polar Fourier series. What is a polar Fourier series equation? X of t is equal to D of 0 plus sum of k equal to 1 to infinite A of k, not the A of k, it is a D of k, my dear students. D of k into cos k omega naught t minus pi of k. This is a formula for the polar Fourier series or the compact trigonometric Fourier series. What is the d of 0? We got a 0.7869. So 0.7869. And sum of k equal to 1 to infinite. What is the d of k? You see the d of k, I already told 1 plus 4 pi k square, and this term is also cancelled. The square term. And it is similar to that of the a of k only, 1.576 whole divided by 1 plus 4 pi k square is under root actually. Under root. Understood, my students? And cos k omega naught t minus tan inverse of 4 pi k. It is not the minus, it is a plus. Actually, here it is a plus. Now it is becomes of minus tan inverse 4 pi k. So x of t is equal to, after substituting all the values of d of 0, d of k and the pi of k, and here the d of k is the square root and the square term, it get cancelled and we'll get the under root here. Following my students? So under root of, so x of t is equal to 0.7869 plus sum of k equal to 1 to infinite 1.576 whole divided by under root of 1 plus 4 pi k square cos k omega naught t minus tan inverse 4 pi k. It is somewhat difficult to understand, my dear student, when I am teaching. But after completing of this one, listen carefully first of all. After completing of this one, you can practice. You can practice the textbooks here. We have the signals and systems by